Welcome to McPlum, simple solutions served daily.
You start by selecting an open model and securing GPU access. This speeds iteration. Once chosen, set up a Python 3.10 virtual environment and install PyTorch matching your CUDA version. Then pip install diffusers, transformers, and other toolkit libs so the inference code runs. Make sure to store model weights on fast storage and test a simple text-to-image call to confirm GPU utilization. That initial run validates your environment and prevents wasted time later. You now integrate the model, load pre-trained weights into the pipeline, and convert to FP16 to fit RAM. Once done, wire prompt conditioning and pick a scheduler, DDIM for speed or PLMS for quality, then set steps, guidance scale, and seed control. Make sure to attach optional modules, an upscaler for higher resolution and a safety filter to catch undesired outputs. If customization is needed, add low array adapters or perform lightweight fine-tuning on a small curated dataset. You finish by exposing the generator via a simple API or GUI and enable batching, caching, and async calls for throughput. Once live, validate outputs across diverse prompts and add deterministic seeds for reproducibility. If you hit failures, check for OOM errors and fall back to a smaller model or enable CPU offload. Also verify CUDA drivers and mixed precision compatibility. Finally, log inputs and outputs so you can iterate on prompts, scheduler settings, or fine-tuning to improve results quickly.
Thanks for watching. Stay juicy and subscribe.